Welcome back to the Deep Dive. It is Monday, January 19th, 2026. And today we are tackling a subject that I think genuinely haunts the dreams of every CTO and data architect out there. We are talking about the absolute paralysis of choice in the modern data stack.
It's the paradox of plenty, isn't it? I mean, we have more tools than ever, but choosing between them has never been harder.
Exactly. You look at the calendar, it's 2026. You'd think by now the industry would have standardized. We should have a VHS versus beta winner. But instead, the lines between a data warehouse, a data lake, and an AI platform are, well, blurrier than ever.
They really are.
It used to be so simple, right? You had a warehouse for your clean, tidy reports, and you had a lake for your messy files. Now, everyone claims to do everything.
That convergence is the headline of the decade, and the marketing departments are not helping. You go to any vendor website right now, and they all say the same thing. Unified, seamless, AI-driven insights. It's just a well of noise.
Which is why we're here today. We're going to cut through that noise. We have a fantastic set of source materials, specifically a comprehensive analysis by Sabin Trusta. He's a data and AI architect with, over 20 years of experience?
Yeah, so he's seen the cycles, he knows where the bodies are buried,
Right.
And his breakdown, the modern analytics platform showdown, is refreshing because it stops looking at the feature lists, which, change every week, and it looks at the philosophy.
And we're focusing on the big three today. The heavyweights that keep coming up in every boardroom conversation: Microsoft Fabric, Databricks, and Snowflake. Our mission is to build a decision framework for you, the listener. We want to move past the sales pitch and figure out which of these actually fits a specific strategy.
Because the best tool for a startup is likely the wrong tool for a bank.
Exactly. So before we get into the nitty-gritty of architecture and billing, let's do the introductions. Assume you know the names, but maybe not the backstory. Give us the origin story for these contenders.
Sure. Let's start with Microsoft Fabric. If you've been in the corporate world, you probably remember Azure Synapse. Well, Fabric is the evolution of that, but it's a massive leap forward. It launched back in 2023 as a purely SaaS product. Think of it as the all-in-one suite that is tightly knit with Power BI.
It's the ecosystem play. If you live in Office 365, you live in Fabric.
Precisely. Then you have Databricks. They are the pioneers of the Lakehouse concept. Their DNA is Apache Spark. They started with code, catering to data engineers and scientists who wanted to get their hands dirty with massive, messy data sets. They've always favored the open approach, open source, open formats.
And finally, the blue Snowflake.
Snowflake. They revolutionized the game by making the cloud data warehouse incredibly simple. They were the first to really nail the separation of compute and storage. Their origin is pure SQL analytics. Their pitch was always, it just works, no maintenance.
What? As we'll see, they have expanded massively into what they now call the data cloud. So we have the unified suite, the open lakehouse, and the simple data cloud. Let's crack open the hood. I want to start with segment 1, the architectural philosophies. Trusta's analysis suggests that the architecture isn't just back-end trivia, it dictates how you work. And he points to Microsoft Fabric's OneLake as a massive differentiator.
It is. The elevator pitch for OneLake is that it's OneDrive for data.
Which implies I don't have to move my files around, because that is the bane of my existence.
That's the promise. In a traditional setup, and I think a lot of listeners will feel this pain, you copy data from a lake, you move it to a warehouse to clean it, then you move it again to a BI tool to visualize it.
So you end up with 3 copies of the truth.
And usually 2 of them are outdated, and you're paying for storage 3 times.
Right.
Exactly. OneLake unifies that. So whether you're running a SQL query, a Spark job, or doing real-time analytics, you're technically accessing the same logical copy of the data. But the real killer feature Shrestha highlights here is something called mirroring.
Mirroring.
Yeah.
That sounds like a magic trick.
It feels like one. It allows operational databases like Azure SQL or Cosmos DB to be replicated into OneLake in near real time without you building an ETL pipeline.
Wait, hold on. No ETL. I don't have to write a script to extract, transform, and load.
No, the system handles the replication. The data just appears in the lake, ready to analyze. And because Fabric is a SaaS platform, software as a service, you aren't managing the underlying infrastructure. It runs on capacities or FSKUs. You buy a block of computing power and everything runs inside that. It feels very much like an evolution of Power BI Premium.
Okay, that sounds incredibly convenient, especially for teams that don't have an army of engineers. Now, pivot to Databricks. You mentioned they pioneered the Lakehouse. I feel like that term gets thrown around so much it's lost its meaning. For the person who hears it constantly but is afraid to ask, what's the core philosophy there?
The Lakehouse is about having your cake and eating it too. I mean, historically, data lakes were cheap storage for massive files, but they were slow, unreliable, and messy. Warehouses were fast and reliable, but expensive and proprietary. Databricks uses the Delta Lake format to bring reliability things like ACID transactions to that cheap lake storage.
So you get the cheap storage of the swamp, but the organization of the library.
That's a great way to put it. And to make it fast, Shrestha highlights their Photon engine.
Is Photon just marketing speak for we optimize the code, or is there real tech there?
No, there's real heavy-duty tech there. Photon is a vectorized execution engine written in C++, Jerry.
Okay, pause. Vectorized execution. You can't just drop that and move on. Break that down for it.
Fair enough. Think of a traditional data engine, like a grocery store clerk scanning items one by one. Beep, beep. That's row-by-row processing.
Okay.
Vectorized execution is like taking a whole basket of items and scanning them all simultaneously in one go. It grabs a vector of data and applies the operation to all of them at once.
So it churns through the hay to find the needle much faster.
Exponentially faster. But the real philosophical hill that Databricks is willing to die on is openness.
Openness, in what sense?
In the file format, Databricks uses open standards like Delta and Parquet. Here's the litmus test. If you decide tomorrow that you hate Databricks, maybe they raise prices, maybe you just don't like the color red, and you want to cancel your contract.
Yeah.
Your data is just sitting in your cloud storage in an open format.
I can just take my ball and go home.
You can take your ball and play on a completely different court. You can read that data with a different engine. There's no proprietary lock-in at the storage layer.
That is a pretty significant safety net for a CTO. You aren't holding my data hostage. Now, compare that to Snowflake. They started as a warehouse, but they're doing the lake thing now, too.
They are trying to bridge the gap. Snowflake's core architecture is multi-cluster shared data. They separate compute, which they call virtual warehouses, from storage. But the magic of Snowflake has always been simplicity. It's a fully managed service. You don't turn knobs. You don't manage indexes.
It's the Apple approach. It just works. Don't ask how.
Right. It handles partitioning automatically using what they call micro-partitions. Think of it as the system automatically filing your documents into incredibly specific, tiny folders based on their content. So when you search for sales in January, it doesn't scan the whole cabinet. It just pulls that one tiny folder. It's brilliant.
But is it open? Can I leave?
Historically, no, it was a proprietary format. But to compete with the Databricks model, Snowflake has shifted to support iceberg tables.
Iceberg. Is that another open format?
It is. It's a direct competitor to Delta Lake. This allows Snowflake to query open formats stored in external storage. They are trying to neutralize that openness advantage Databricks has held for so long.
So everyone is encroaching on everyone else's territory.
That is the defining trend of 2026.
Let's move to segment 2. We have to talk about AI.
Yeah.
It's 2026. If you aren't talking AI, you aren't talking tech. But Shrestha makes a distinction here. It seems like the platforms have very different ideas of who is using the AI.
That's the key. If I'm an organization that says we're AI first, and by that I mean we build our own models, Databricks is the heavy hitter.
Why is that?
It goes back to their roots in Spark, but specifically, Shrestha highlights their acquisition of Mosaic ML. This was a massive strategic move. It allows companies to train and fine-tune their own large language models cost-effectively.
So this isn't just calling the ChatGPT API and paying OpenAI. This is building your own corporate brain.
Exactly, owning the IP. And they have something called Lakehouse IQ. It's a natural language interface, but it's tuned to understand the specific jargon of your business data. Plus, they have deep integration with MLflow for managing the entire lifecycle of a model, tracking experiments, versioning models. It's a workbench for data scientists.
Okay, so Databricks is for the builders, the engineers who want to get under the hood. What if I just want to use AI to make my SQL queries smarter? I don't want to manage a model. I just want the result.
Then you look at Snowflake. They've focused heavily on AI in the warehouse. They launched Cortex AI. These are built-in SQL functions.
Built in. Like select to know.
Exactly. But it's A-summarize or A-classify. You can literally write a SQL query that calls an LLM to summarize a text field or classify customer sentiment right there in the database. You don't have to move the data out to a separate machine learning platform.
That sounds incredibly convenient for a team that already knows SQL but doesn't know Python.
It democratizes AI. It makes every SQL analyst an AI engineer. And for developers, they have Snowpark, which lets you run Python code inside Snowflake's security boundary. They also introduced Snowpark Container Services, which essentially lets you run custom workloads like model serving directly on their infrastructure.
So Snowflake is bringing the code to the data. Where does that leave Microsoft Fabric?
Fabric is betting the farm on the Copilot era. The integration of Copilot is everywhere in data science, data engineering, and Power BI. It helps you write code. It helps you generate insights. It's about productivity enhancement.
It's the assistant, not the engine.
In a way. And they have a low-code angle, too, called Data Activator. It's a fascinating tool that triggers actions from data patterns without you needing to write complex scripts. It's very business user-friendly. However, Shrestha notes that for heavy-duty model lifecycle management, Fabric still relies somewhat on Azure ML. Databricks keeps that all in one platform.
Got it. So Fabric for assistance and low-code, Databricks for deep engineering and custom models, Snowflake for SQL-integrated AI functions.
That's a fair summary.
Let's move to segment 3. Data sharing. We live in a connected world. Supply chains are global. Partnerships are digital. I remember Snowflake making a huge splash with their data sharing capabilities a few years back. Is that still their crown jewel?
It is definitely a stronghold. Snowflake operates what you might call a global hub. They have SnowGrid, which allows for seamless cross-region and cross-cloud replication.
And the data marketplace.
Huge. If you are on Snowflake, you can share live data with a partner who is also on Snowflake without copying a single file. It's instant. They also have data clean rooms, which are crucial for industries like advertising and healthcare, where you need privacy-preserving collaboration.
But the catch is, the other person has to be on Snowflake.
Generally, yes. It's a very beautiful, well-maintained, walled garden. If you're inside, it's paradise. If you're outside, you can't see in. This creates a powerful network effect. Vendors tell their suppliers to get Snowflake so they can share data easily.
Which forces everyone into the club. Databricks takes the opposite approach with Delta sharing. Let me guess, open again.
You guessed it. Delta sharing uses an open protocol. You can share data with a client who doesn't use Databricks, as long as they have a client that can read the protocol, which could be Power BI, Tableau, or just a Panda script. They can read the data.
That seems more flexible for a messy supply chain where everyone uses different tools.
It is. It's messier to set up than Snowflake's one-click sharing, but it's universally compatible. And Databricks ties this together with Unity Catalog, which is their governance layer. It tracks data and AI models across different clouds, which is becoming essential for big enterprises.
And Fabric, you mentioned OneLake earlier. Does that help with sharing outside the Microsoft bubble?
Fabric has a very cool feature called shortcuts. You can mount data from AWS S3 or Google Cloud directly into OneLake.
Wait, mount it so I don't move it.
Correct. It stays in Amazon S3, but it looks like it's in your OneLake. It creates a virtualized data estate. However, the source material notes a critical limitation here. While Fabric allows this multi-cloud data access, the compute, the actual processing, is currently Azure only.
Right. So the data can be anywhere, but the engine is in Microsoft's house.
Exactly. You have to bring the appetite to the kitchen.
Let's talk about everyone's favorite subject, the bill, the cost models. This is usually where the decision gets made, isn't it? Or at least where the biggest fights happen.
It's certainly where the arguments happen. And the models are drastically different.
Start with Snowflake. I've heard it described as a taximeter.
That's apt. Snowflake uses a credits model. You pay for the time the virtual warehouse is running. If you run a query for 62 seconds, you pay for roughly that amount of time.
That sounds great for efficiency. I'm only paying for what I use.
It is fantastic for spiky workloads. If you have a report that runs once a day, you spin it up, run it, shut it down, auto-suspend saves you money. But the con is predictability. If you leave a warehouse running, and this happens all the time, if you write inefficient queries that scan way more data than necessary, the meter is running fast.
Like leaving the taxi idling in the driveway while you run inside to get your wallet.
An expensive taxi.
Yeah.
And suddenly your CFO is knocking on your door asking why the data budget tripled this month. Now, Databricks is a mix. You have the DBU Databricks unit plus the underlying cloud VM costs.
That sounds complicated.
It can be. It's consumption-based, and it's highly elastic. You can spin up massive power for an hour to crunch a huge AI model, then shut it down. But calculating the total cost of ownership requires a spreadsheet. You need strong governance to ensure engineers don't spin up a massive cluster and go to lunch.
Or leave it running over the weekend.
The dreaded weekend cluster, it happens. But Databricks is pushing serverless SQL now to mitigate this, making it feel more like Snowflake.
And Fabric. You said it was like Power BI Premium.
Fabric uses capacity blocks, or FTUs. You buy a fixed amount of computing power, say an F64. That is your capacity for the month.
So it's predictable. It's a flat rate.
Yes, the billing is predictable. And they have a feature called smoothing, which is interesting. If you have a short burst of activity that exceeds your limit, they smooth it out over the 24-hour period so you don't get penalized immediately.
If I buy the capacity and don't use it?
You paid for it. It's like a gym membership. If you don't go, you still pay. And conversely, if you consistently exceed the limit, you get throttled. Things slow down.
Okay, so Snowflake for spiky, precise billing. Databricks for elastic, massive scale where you control the hardware. Fabric for predictable, flat rate capacity.
That's the simplified version, yes.
So we've looked at the architecture, the AI, the sharing, and the cost. Let's get to the verdict. Save and Shrestha provided a decision framework. If I'm a listener standing at this fork in the road, how do I choose?
Shrestha breaks it down beautifully. You choose Microsoft Fabric if you are already a Microsoft-centric shop. If your company lives on Office 365, uses Power BI for everything, and you want a unified path from ingestion to dashboard, Fabric is the winner.
It's the path of least resistance.
It reduces the friction of integration. It is excellent for BI and corporate reporting. Now, you choose Databricks if you are a tech-native company. If you are doing massive-scale data engineering, processing logs, or building custom AI products, and you want open formats with no vendor lock-in, Databricks is your home.
The engineer's choice.
And you choose Snowflake if you want it just works. If you want a SQL data warehouse with zero maintenance and your priority is data sharing, especially in industries like finance or retail, Snowflake is the gold standard.
Governance over flexibility.
In a way, yes. But here is where it gets really interesting. Shrestha reveals the hybrid reality.
Let me guess. Big companies don't pick just one.
Rarely. Large enterprises often use multiple platforms. A very common pattern, and I see this all the time, is using Databricks for the heavy data engineering and machine learning.
The kitchen?
Right, the messy kitchen where the raw ingredients arrive. Databricks cleans it, processes it, runs the AI models, and then they feed that curated high-value data into Snowflake or Fabric for high concurrency reporting and dashboards.
So Databricks creates the meal, and Snowflake or Fabric serves it to the customers in the dining room.
That's a great analogy because Snowflake and Fabric are often better at serving thousands of concurrent users running simple reports. Databricks is better at the heavy lifting.
But watching these three converge is fascinating.
It is. Snowflake is adding Python and Iceberg to look more like Databricks. Databricks is adding SQL warehouses to look more like Snowflake. Fabric is adding AI to look like, well, the future.
They're all trying to eat each other's lunch.
They are. And for the buyer, that's actually a good thing. Competition drives innovation.
So what does this all mean for the listener? We've covered a lot of ground.
The summary is that there is no single best platform. If someone tells you Platform X is the best, period, they are selling something. It comes down to your team's skills. Do they know SQL or Spark? It comes down to your ecosystem. Are you Azure loyal or cloud agnostic? And your primary use case, is it BI or AI?
It's not about the logo on the software.
No. And I'll leave you with this final provocative thought. As we look at this 2026 landscape, the most successful companies aren't the ones that just pick the right tool.
Yeah.
They are the ones building a federated architecture, meaning they build a system where these platforms talk to each other. The real winner is the organization that avoids data silos. If your Databricks Lake can talk to your Snowflake warehouse and your Fabric dashboard, you've won. It doesn't matter who processes the data as long as the business can use it.
That is a powerful place to end. Don't look for a savior tool, look for a strategy that connects them.
Precisely.
This has been an incredibly illuminating deep dive into the analytics showdown of 2026. A big thank you to Save and Shrestha's analysis for guiding us through this maze. And thank you to everyone listening. We'll catch you on the next deep dive.
Goodbye, everyone.